Welcome back to the channel. Today, we'll be discussing binary classification metrics, including accuracy, precision, and recall. These metrics are essential for evaluating the performance of models used in tasks like diagnosing diseases, spam detection, or fraud detection. Let's dive into the slides. First, here's an outline of what we'll cover. We'll begin by understanding the possible outcomes of binary classifiers, followed by defining and analyzing confusion matrices. Then, we'll explore accuracy, precision, and recall, discuss the Precision-Recall Tradeoff, and finally, interpret ROC Curves and AUC. By the end of this video, you'll have a comprehensive understanding of these critical evaluation metrics. Binary classifiers produce four types of outcomes. A true positive occurs when a positive result is correctly predicted, while a true negative is when a negative result is correctly predicted. On the other hand, false positives happen when a negative outcome is incorrectly identified as positive, and false negatives occur when a positive outcome is incorrectly identified as negative. A confusion matrix is a handy tool to summarize these outcomes. It's a table with rows representing actual values and columns representing predicted values. For example, in a rapid COVID-19 test, true positives and true negatives represent accurate predictions, while false positives and false negatives indicate errors. This table helps us visualize model performance at a glance. Now, let's break down the metrics. Accuracy measures the proportion of all correct predictions and is calculated as the sum of true positives and true negatives divided by all outcomes. Precision focuses on positive predictions, showing the proportion of correct positive predictions. Recall, on the other hand, measures how well the model identifies actual positives. These metrics are critical for understanding how well a model performs in different scenarios. The Precision-Recall Tradeoff highlights a key challenge in model performance. Adjusting the probability cutoff for classification impacts precision and recall. Lowering the cutoff increases false positives while improving recall, whereas raising the cutoff reduces false positives but lowers recall. This balance is crucial for optimizing model performance based on the task's requirements. ROC curves and AUC provide a broader view of model performance. The ROC curve plots the true positive rate against the false positive rate at various thresholds, showing how well the model distinguishes between classes. The area under the curve, or AUC, quantifies this performance, with higher values indicating better distinction between positive and negative classes. Finally, let's look at an example using Python. Here, we calculate accuracy, precision, and recall for a set of true labels and predictions. This code snippet demonstrates how easy it is to compute these metrics using scikit-learn, a popular Python library for machine learning. These tools simplify evaluating classifiers and interpreting their results. To summarize, binary classifiers produce outcomes that we can evaluate using metrics like accuracy, precision, and recall. The Precision-Recall Tradeoff and ROC curves help us understand trade-offs and overall performance. By mastering these concepts, you'll be equipped to assess and improve models effectively in various applications. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.